Guru, made for you.
Now we're going to start a chapter on systems of equations, specifically linear equations. So what is a system of equations? A system of equations is many equations on the same coordinate plane, or specifically two or more equations on the same coordinate plane. So a system of equations is two or more equations with the same variables, or they're on the same coordinate plane. So they're on the same coordinate plane. So the solution to a system of equations is where all the lines intersect. So there are three types of systems of linear equations. So we're going to be studying linear system of equations, which means graphs, equations that make a line. So it's where a bunch of lines intersect. So there are three types of system of linear equations. So there are three types. The first type is the independent system. The second type is the dependent. And third type is the you can barely see that, inconsistent system. So the inconsistent system is the system where the lines don't intersect at all. So they're parallel lines because they don't intersect at all. So the solution is none. So there are no solutions. There are no solutions at all because they're parallel and they never intersect. And a dependent system is where the lines coincide or they overlap over each other. So there are infinite solutions because the lines are on top of each other. The lines depend on each other. That's why it's the dependent system. The lines are on top of one another. The final system, is this what I call it? Yeah. The final system is the independent system. And the independent system is where they have one solution because they all meet at one point. That's the solution. So this one has one solution. So the independent has one solution, the dependent has infinite solutions, and the inconsistent has no solutions. So let's actually try some equations out. So first let's try this example here. So the first one we're going to try is y equals x, and y is equal to 6 minus x. So we have to find both of these equations. So to graph on this coordinate plane right here, we should put it in slope-intercept form. This one's already in slope-intercept form. Y is equal to x plus 0. So 0 is the y-intercept, so it goes through the origin right here. And the coefficient of x is 1, so it has a slope of 1. So it goes there. It just goes right through. Let me try this. That's our first line. Now the second line is y equals 6 minus x. So all we have to do is put the x term first so that we get it into slope-intercept form. So y equals 6 minus x is the same thing as y is equal to negative x plus 6. We just switch them around. We just switch the terms around. So the slope is negative 1 and the y-intercept is 6. So if the y-intercept is 6, I'm going to use a different color. That's the y-intercept. Negative 1 is the slope. So we get this point as our point of intersection. So this is our solution. So that point is 1, 2, 3, 1, 2, 3. So the solution equals 3, 3. And that is our solution. And this is a independent system because it has one solution. Independent. Now let's try this one here. Let's try this one. So if I feel like I'm going too fast, you can pause anytime and replay it. This is a video, so you're free to do that. So the next one we're going to see is 6x plus 4y equals 2 and 3x plus 2y is equal to 1. So let's see. So if you put this into slope-intercept form, I like putting it in slope-intercept form. You can use x and y intercepts. That's totally fine. X and y intercepts are usually faster. I like slope-intercept because I feel it's easier. Because usually x and y intercepts might be a fraction, and fractions are hard to deal with. So I'm going to be doing it in slope-intercept, but you can do it in x and y intercepts. So 4y is equal to negative 6x plus 2. So y is equal to negative 6 over 4x plus 2 over 4 is 1/2. So this is also y is equal to negative 3 over 2x plus 1/2. This one would be 2y is equal to negative 3x plus 1. So y is equal to negative 3 over 2x plus 1/2. So you might notice the equations are the same, which means they're the same line. So this would be a dependent system. But let's just graph it. So 3 over 2x plus 1/2. So 1/2 would be over here. So 3 over 2. So 1, 2, 3 over 1, 2. The point would be there. 1, 2, 3 over 1, 2. There. Take out our line. One. Yeah. So our first line. So that line is. So this is both lines basically, because they're the same thing. Just put another line over it. So this is a dependent system. And because it's a dependent system, there are infinite solutions. So the solution will be infinite solutions, because this is a dependent system. Now let's look at another one. So this one would be the equations for this would be y is equal to 3x plus 1 and y is equal to 3x minus 8. Yeah. So these are both in slope-intercept form already, so we can just graph straight away from this. I'll use black. So this one is black. So y equals 3x plus 1. The y-intercept is 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. Okay. Alright, we can draw our line. And we should use a straight edge when we graph because it looks neat. It's not a perfect line, but it's a computer. That's our first line. Second line, I'll use this color. So y equals 3x minus 8, so our y-intercept is negative 8. 1, 2, 3 over 1. 1, 2, 3 over 1. 2, 3 over 1. Okay, we can draw a line. As you can see, these lines are parallel because they have the same slope. If you look at it, they have the same slope. So that means they're parallel. Parallel lines. So that ultimately means this is a inconsistent system. So the solution is equal to S, or no solution. As you can see, these are the three types of systems, and this is how you use the graphing method, the graph, to solve a system of equations. This is one of 5 ways to solve a system of equations. Thank you for watching. Guru.